We're going to look at separable differential equations, and this is one of the ways that you can actually solve a differential equation. We'll talk about how you actually solve these kinds of differential equations. So these are a specific type of differential equation. If it's a separable differential equation, it's going to take one of two forms. Let me see how much space I got to write here. Okay, it's a differential equation that either looks like this, dy by dx equals f of x over g of y, or dy by dx equals f of x times g of y, or I guess technically there's one other form we can write, dy by dx equals f of y divided by g. I don't want to use, I want to keep the f and y the same, so let me fix that. G of y over f of x. The point is that you can write it as two functions multiplied together, one of which only has x and one of which only has y. Or technically dividing also works because division is just 1 over a function, so you can multiply. You can rewrite whatever is in the denominator as a new function of y. But this is called separable because it can be rewritten as g of y dy equals f of x dx. So the point is, the reason why we care about being two functions multiplied together, one that only has x and one that only has y, is I can basically treat these differentials as variables and multiply or kind of rearrange them. I can treat the functions as variables and multiply and rearrange them, and I can get something that's in this form here, where one side only has y's and one side only has x's, and hence separable. I can separate the x from the y. And so that's how we solve a separable differential equations. So first you separate and then you integrate both sides. So this is just using tools you already know with like a slight tweak here. So for example, find the general solution for y prime equals x squared minus 4 times 3y plus 2. So we're going to write this using this notation. Dy by dx is equal to x squared minus 4 times 3y plus 2. Now I need to separate all of my y values from all of my x values. So I'm going to divide by 3y plus 2 on both sides to get dy by itself. And I'm going to multiply both sides by dx to get x squared minus 4 times dx. Then I'm just going to throw an integration sign on there to integrate both sides. The left side, I'm going to skim past this real quick if you need to pause and check or ask me to check. This will give me 1/3 ln of y plus 3y plus 2 is equal to, and then on the right side, 1/3 x cubed minus 4x plus c. So now technically there's a plus c from the y expression and a plus c from the x expression. But these are both constants that are unknown, that are specific but unknown values. They depend on what the initial conditions you have. So they're not the same c. So when I subtract the cy over to the other side, I can basically write it like this. I can get rid of the cy's on the left, but on the right now I have a cx minus a cy. Those aren't the same c, so I'm just going to replace them with another c that I'm going to call c. And what this ends up being a shortcut in math that we'll deal a lot with in this context, where we just, any constants that interact with c, we just swallow them up into the c and call them c. Now, if we want to write this in terms of, technically we've solved the differential equation. This is a solution. If you go back and plug it in, you'll find that you get that. But it's really hard to check this because we don't have y equals to take the derivative of this. So let's go about actually kind of doing the algebra to isolate y to find the general solution. So first thing I'm going to do, I'm going to multiply both sides by 3. And that will give me x cubed minus 12x plus, it would be 3c, but again, any constants we're just kind of absorbing into the c there. Just double checking against the work I've already done. Now I need to raise both e to both sides to get rid of the natural log. So e to the ln 3y plus 2 is equal to e to the x cubed minus 12x plus c. And if you need to review your exponentials and logarithms, this should become second nature by the time we get to the AP test, by the time we get to the quiz. So check in with me if you need support on this. And that will simplify to 3y plus 2 is equal to, and I'm going to do a little tricky thing here, e to the x cubed minus 12x times e to the c. Because remember, if you've got exponents, you can rewrite them. If you add values in your exponent, you can rewrite it as multiplying the bases times those exponents. And e to the c is just going to be some new arbitrary constant. Because again, e to some constant is some other constant, so we're just absorbing any constants into that c value. Now we can do the last bit of algebra here to get c e to the x cubed minus 12x. That's what we already had on this right side. I'm going to subtract 2 to get rid of this 2, and then I'm going to divide by 3 to get rid of that 3. And so this right here is the general solution to the differential equation y prime equals x squared minus 4 times 3y plus 2. If they gave you initial condition, if they said, for example, y of 0 equals 3, I could plug in x equals 0, I could plug in y equals 3, and that would let me solve for c. Or if they gave me y of 1 equals 1, same idea, we can plug those in. Let's look at one more example here to kind of close this out. And that is find the solution for 6y prime is equal to 2x plus 1 times y squared minus 2y minus 8. And the initial condition is given here of y 0 equals 3. So we're going to pull all of these y values to the left-hand side. So we're going to get 1 over y squared minus 2y minus 8 dy, and then I'm going to divide the 6 onto the other side, just because I find it's typically easier to deal with the 6. It's easier to deal with the constants on whichever side doesn't have things in the denominator, if you end up with things in the denominator. So that will give me 1/3 x plus 1/6 dx. And you can just look at this of, you can kind of start to see how this left side, right side is going to be pretty easy to integrate. If there was a 6 up top, it might get a little confusing. So we have to integrate both sides. The right side's pretty easy to integrate. Hopefully it's going to give us, 1/6 x squared plus 1/6 x plus c. And whichever side, like I said, whichever side tends to have the x, that's where I'm going to put my c. Now, on the left side, we have the integral of y squared minus 2y minus 8. We don't know how to integrate that right off the bat. But I'm looking at this, and first thought I have is, can I factor that? And in fact, we can. Y minus 4, y minus 2. And then when I see this factored, I think, okay, this is partial fraction decomposition. So I'm going to come up here. I'm going to say 1 y minus 4, y minus 2 is equal to a over, check how I've written it here. I have just completely skipped over it, but we'll do it real quick here. Y minus 4 plus b times y minus 2. So that's going to be a times y minus 2 is e plus b times y minus 4 is equal to 1. So if I say y equals 2, that means that b times negative 2 equals 1, b equals negative 1/2, y equals 4 says that a times 2 equals 1, so a equals 1/2. Okay. And then coming back here, that means we get the integral of 1/2 over y minus 4 minus 1/2 over y plus 2. I have completely botched that, and yet somehow picked the right b from that. I am sorry for the sloppiness there. That should be plus. That's what you get for trying to do too much in your head. If there's an error, please double check, pause here, look through all that, make sure that makes sense, and then let me know if you see a problem. Okay, coming back here, that means we get 1/2 of ln of y minus 4 minus 1/2 ln of y plus 2 is equal to 1/6 x squared plus 1/6 x plus c. We need to solve for the y values. I'm just checking my stuff here. That does look like what I had solved earlier, so that's good. I'm going to move the 1/2 to the opposite side to multiply everything excuse me, by 2. ln of y minus 4 minus ln of y plus 2 is equal to 1/3 x squared plus 1/3 x plus c. Again, we don't need to worry about multiplying c by constants. Natural logs can be combined like so, because remember, if you have natural log and they're multiplied, you can add them. If they're added, you can multiply them. If they're subtracted, you can divide them. 1/3 x squared plus 1/3 x plus c. Raise both sides to the e power. 1 minus 4 y plus 2 equals e to the 1/3 x squared plus 1/3 x plus times e to the c. Y minus 4 over y minus 2 is equal to c e to the 1/3 x squared plus 1/3 x. And at this point, this doesn't simplify any better algebraically, so we'll leave it here. But we do need to find our initial conditions, so y of 0 equals -3. That will be plugging in -3 for the y values, plugging in 0 for the x. So I plug in x equals 0, this whole e to the whatever goes to 0, or goes to 1. And then if I plug in -3, I get -7 over -5, which means that c is equal to 7 over 5. So y minus 4 over y minus 2 is equal to 7/5 e to the 1/3 x squared plus 1/3 x. This is probably a bit more complicated than you'd expect to be asked to do on the AP test, but it does give you a good sense of everything that could be involved. You could have complex integrals and then some kind of complexity when algebraically cleaning it up.